A function can be treated as a variable. That's what the beauty of Go is. So that you can do functional programming. A function can be treated as a variable so that we can do functional programming. That is the thing in Go actually. So what I do here is I create a map, make of map of string comma any. Maybe I give it as 5. You can give the size length of the map, but it's okay. Nothing like that. Now what I do is I create a simple function. What I got to store in the map is I store different types of variables, including functions. So I create a function map1 of the key is greet, the value is anonymous function of hello world. The value of the map is an anonymous function. The next one is map1 of maybe add is another anonymous function but with different type. So this is one function, this is another type of function. Third one, I create a function type f1 is func of integer and then integer. So what I create here is I create a where fn1 is function equal to function of return I1 minus I2. So map1 of subtract equal to fn1. I create a concrete function multiply a comma b of integer return a into b. Okay, so I create map1 of multiply equal to multiply. So you see we have these kind of types. We have these kind of types, and I function. I have got these values and all. Okay, then how can I write the divide? Okay, what I write divide is I create a function divide. I take variables. Instead of returning the divide, I return a function. So I give divide map1 of divide equal to div. You see that this very I mean why I'm telling is what all you can do at least at a basic level so that you can understand the concept. Since map the value of the map is any, technically you can store any data. That's what we already knew that it's nothing that we have been doing right now. We already did it. That any value is not confined only to a, a simple function or a simple variable. That any value is that any value is technically anything. It's not just only an integer, only a string, or only an array, or only a slice. Not like that. It can be of anything. That's what actually the meaning of that, as long as it's a valid type in Go. So what is the meaning of valid type? Valid type could be any type in Go language. It could be a function, it could be a structure. In fact, it could be even a slice, it could be a structure, it could be even another map. There is no limitation for what should be the value. Okay, that's what it is. So these are the values that we give to any. You can have a look at it. And then what I got to add over here, we add a greet function, we add a normal anonymous function, and then we also add a on the greet function, normal anonymous function. We add a typed function. That means a type we have not typed function. We created our own type and then created as a function. Three things we have added. After that, we have created a function called a concrete function called multiply, and then assigned inserted into that map. And then we have created a function called division. Actually, it returns another function. That's what the division for function does. It returns another function that also got added. So now what I would like to do is I would like to iterate through the map, okay, and then execute all the functions. That's what I want to do. I would like to iterate through the map and then execute all the things. How can I iterate through the map and then execute all the things? In fact, actually, I don't need to give this int and int. The reason is it's going to return a function. Okay, and then I don't need this, but it return a function that function give a by b. Whenever I want, I can execute because these a by b only we are using. Then why should you return with some parameters when the parameters are not going to be useful? So different types of functions we have created. Now, generally, what I do is if I'm not very much clear about okay what type these types are, okay, I'll tell you the simple trick. Okay, so let me iterate and execute. That's what I have to do. That is very important actually. So I create a loop for key comma value range of map 1. I get a key and then I get a value. You know what the key is? Key is just a string. You know what the value is? Value could be, okay, let me go and give map 1 of, uh, okay, done equal to true. Map 1 of value equal to maybe 100. Map 1 of cities equal to string of Bangalore. Now you see that this map is having so many types of data. A function, a function, a function type, sorry, a function type variable, a concrete function, a division function, but it's gonna return another function, a boolean value called 100, and something called like a slice. Okay. Generally, what I do is I know that actually each and every type is because I have to do type assertion. Then only I can iterate through all the variables. I know what each type is. But how do you do type assertion? Generally, you put switch, the value comes as v dot type, you know that already. So each type I want to execute. So what I do is I put fmt dot println key is, I just put it as key. I have to put the case, let me put the case as function. Let me go with the same order. Key is key. That means I just print the key, and then the value is if with the value is if a function, okay, fmt.println, okay, type of value, just to print type of value is reflect dot type of value. You get the type of the value, that means here, and then if function execute it. So what I do, I know that this is this, so value dot assert it to function and execute it. So this whole thing, because it's a value, this is, you have to assert it as a function because the first value is stored inside a function. This is the function. So assert it back. So assertion is not confined only to values. The assertion can also be, you can assert it to function. Since this got asserted to a function, execute it like a function. Okay, you see that, okay, this is creating a lot of issues for me. It's quite different. Uh, I put I put it as like this, ret, and then you can also execute it like this. And then I just put a new line so that I can have clarity. Okay. If I run this, so key is greet, type of value is this, it got executed, and there's a space. Only that got caught. The next second thing, what is the second thing? Second thing is this function. So take this, case this, print the value. Let me create some variables called a comma b equal to 20 comma 10. So ret, now the ret is a function of the type, so 10 comma 20, sorry, a comma b, and you get a result, print the result. Because it's a function, I got executed, but you know what is it. It's the second one. What is the type of the third one? The type of the third one is not this, but it is a fn, because the type is fn. So I need to capture what the third one is. Case fn, that means that got to be the type. Then I get fn. Fn is also the same type, so I can execute it. Let me run it. Add, substitute. You got multiply as well. How did you get multiply? The reason I got multiply is multiply is also the same type of this. That's the same type. Multiply is also same type. The only name is different. Okay, that's fine. Then the fourth one, what this contains, the fourth one is what division. What does it contains? This got to be the syntax. The fourth one is going to return. You see that that's a technically that's pretty important. The fourth one is a function that returns another function. This is the type. So just showing you how you can do this, got to be a function. So print the type key, print the value. Then I got ret. Ret is not R is what actually R is a function. So make it as fn1, maybe fn of executed, you get the result, print the result. So why ret is returning a function? Because this is what the syntax is, the whole thing. It got to return a function, so ret is giving a function, you execute the function, get the result and execute it. See, why I'm doing all the things is for you to know that, okay, these many things you do. It's not just, map is not just to store normal variables. You can do many things, that can store many things in the map. And then it is integer, it is sorry, it is boolean, it is integer, it is slice. Let me go with the slice first. Case string, this got to be the type, print it, get the value. Okay, since I know that it's a slice, index comma value, range of ret, because ret itself is the slice, fmd.println index is I, value is v. After doing that, put a new line so that I can understand it's got to be a new line. And the next thing is integer. Okay, just print the value and give a new line so that you can understand. And the next thing is boolean, and the next thing is string. Bool string. So get the value, get just print the value, nothing we are doing. This is what we are doing. So the first one, actually it picked the slice first because we don't know, the maps are not ordered. We do not know the order. The first one, it picks the slice. These are the key and values, index and values of the slice. The second one, it picked the greet function. It has executed. The third one, it has picked the add function, which is this is the type. It has executed the addition of A and B. Subtraction, which is called fn. Fn, you see that the subtraction is fn. I don't know why it gave 0. Let me check it. The fn, fn, where is fn? The one, yeah, sub is fn. Where is sub? Sub is fn1. So what fn1? Okay, I'm doing i1 minus i2 instead of i1 minus i2. I'm just giving i1 minus i1. If I go for fn, it gave 10. Multiplication, it got the concrete function. Division, it has done with the division and all. So this is how you can store values inside the map. Okay, and then you can execute them as well. So map is not confined. It's not just with one type, so that map any is very powerful. You can store anything inside any, as long as the type is safe type. That means the type is known to the compiler. Type safe is the type should be known to the compiler, as any is also type safe. Yeah, okay. It should be known to the compiler. You can do that.